Okay, so diffraction is kind of weird. What happens is if I have two walls here and an opening or a slit that the wave can go through, what happens is the wave doesn't just go straight through and then continue in a straight path that way. What happens is when it goes through this gap, it's going to bend. It's going to bend around that opening. If you close in the gap even more, and if you close it to the point where the gap is the same size as the wavelength of the wave that's going through it, you're going to have a lot of bending here. So if I had a light that was coming through here, it would not just light up right here where it would be the size of the opening. It's going to light up this entire side, even though this part of the wave isn't getting through. So this is interference. That's diffraction. And you can watch this video here if you have time. Go ahead and take a look at that. And it's easier to see it when the waves are actually moving. Interference is when two or more waves are going to overlap with each other. So wave interference, like we talked about with sound, when two waves overlap, they either are constructive or destructive. The same thing happens with light. So if you have constructive interference with light, it's going to be even brighter. If you have destructive, it's going to make it more dull, so you can't see that light as much. So those are the different aspects of light, which is a very small portion of the electromagnetic spectrum. So let's go ahead and orient ourselves to this here. One of your homework assignments is actually to draw this, or a version of this that you can find online that makes sense to you. But this entire electromagnetic spectrum tells us all these different waves, electromagnetic waves. Visible light makes up this small sliver right in the middle. It's not much, and it goes from red through to purple over here, or violet. And the different colors depend on the wavelength or the frequency of the wave that you see. So a higher frequency wave is going to show up as blue or violet, and a lower frequency wave is going to show up as red or orange. The lowest frequency waves are radio waves, and then it goes to microwaves, and then infrared. Notice that infrared is underneath or behind red, which is where it gets its name, infrared. And then our little visible light here. And then we have ultraviolet, or above violet, right? Because our last color over here is violet. And then X-rays and gamma rays. So gamma rays are going to have the highest frequency and the most energy. So the more the frequency, the higher the energy. Radio waves are going to be low frequency and very low energy. So let's talk about some characteristics. Low frequency, large magnitude means that they're going to be safe. So radio waves, microwaves, infrared radiation, visible light. As you get farther into infrared, there are some dangerous infrared, as we'll see. Then if something is too bright, too much light, that can also be dangerous. So these are roughly safe with some caveats. The higher the frequency, smaller magnitude, you're going to have more dangerous. So UV, ultraviolet radiation is going to cause sunburns, which lead to different types of cancers. So then you have X-rays, which are also damaging to the cells of your body, and gamma rays, which are very, very high energy and very dangerous. Light makes up a very small part of the electromagnetic spectrum, as we talked about earlier, and does not need a medium to travel through. Again, it can travel through space. That's how we get all these light from the sun, is because it's able to travel through space between the sun and hit the earth. Okay, so we're going to finish off talking about each of the different waves shortly, very briefly, and I'll be right back with that.